413 tension with Atwood Machine. I should call it that. And I'll have to put the worksheets on there, the problems to do. But you're going to do just going to do problems that look like the ones I'm going to show you here. All right. So here we go. Now this is kind of neat stuff. It's kind of fun, kind of interesting, and Atwood Machine, invented in 1784 by Reverend George Atwood, London, England. He was able to verify laws of uniform accelerated motion, it says with that. Well, the usefulness of this is an interesting thing. This is the one that the Atwood Machine is, this one you see on this side. And we know that it's like a little device. I mean, even though he invented to measure it, but surely someone in earlier ancient times invented something like this to make a pulley to lift things up. But anyway, first let's look at the regular one, a pulley. And on one side we have a weight, and another side we have a weight. And it says X and Y. Now, did I give the masses? Yes. It said, calculate the acceleration of the system and the tension in the cable connecting them. It's like over a little pulley. Okay? So it says that X has a mass of 20 kilograms. Y has a mass of 10 kilograms. And if we let this go right now, what's going to be the acceleration of the system? Well, it's kind of like the one I showed you in the last lesson. You can already tell which side's going to go down and which is going to go up. If I let go of this, 20 and 10, obviously this is heavier, so it's going to go that way. It's going to rotate, what do you call that, counterclockwise in that direction. So we can let this way be positive, and this way would be negative. You got to think about now the rotation. If you're moving in this way, it's positive, that way negative. Now sometimes we can give you unknown weights, or you won't know what's going on, and then you have to guess a direction, as I told you. All right, so to figure it out, we do it the same way we did in the other problem. We have to make a net force equation for object X, or weight X, and a net force for weight Y. So for X, the block X, or block X, I could call it that. All right, the net force on X is equal to, in the cable we have a tension. Now, I could put it up here if I wanted to, but it'll be the same number, whether the tension is here or there. It's just strung over like a pulley. You could probably even do this like just stringing it over a tree branch or like a broom handle or something. Broom handle would be better because it wouldn't be much friction. If you didn't have hardly any friction, it would be better. I mean, a tree branch might not be so good unless you're like skin down the tree or something to make it real slippery there. Then you could probably use it. The same thing will be true. But of course, you're going to have friction. But the point of this is to make the friction be very minimal. Just a little bit of friction you might have in the axle of the little pulley as it spins. Okay, so the net force on X will equal, first of all, let's think about the forces involved. Okay, we got the tension in the cable. All right, it's the same tension there, and up here. And you also have gravity. Weight is pulling it down here. F weight for X and F weight for Y. Okay, so for X, the two things that are most directly around it are the weight. We'll say F weight of X is one force, and you have the tension in the cable. Now let's just think about that. Which one is positive, negative? Weight, we're going to let that direction be positive and that one be negative. So this will be a positive weight, positive. And of course, the other one, the tension now, is going to be working against it falling down. Again, if the tension wasn't there, it's going to accelerate down even faster. So tension is negative. So we'll put it in the weight, the net force. And if you want to put MA, you could. I guess I could go on and do that. MA will equal, weight is mg. Now, if you want to go off to the side and say for X, F weight is mg, and then calculate it, you could. I'll just do it right here. But watch carefully. I know the whole thing is going to be positive, okay? And then the other one, the tension is going to be negative. So I'll just put maybe minus t. Just let that come out. So m times g minus t. So ma equals, the mass of x is 20 times 9.81. And I'm going to let the gravity be, well, the whole number is going to be positive. We're not going to worry about that. We can keep thinking of it as a force. On the other side, it'll be negative, but not yet. 20 times that minus t. So we can also plug in the mass, which is, for x, what was it? 20. So 20 times a equals 20 times 9.81, 19.6, or you can actually make it just 20 as well, because it only had 2 sig figs there. I'll just keep it that way. 19.6. Well, we'll do it right. 20. Let's keep it 19. I'm sorry. Okay, because when you're copying it down for a sample problem, it really only has 2 sig figs. But for now, 19.6 minus t. 20a equals 19.6 minus t. Here is one of our equations. All right. For the other, I should try to fit it over here. All right. I think I can make it. All right. For object y, the net force on y will equal, does that all fit? Yeah. I just got to back up. I'm actually stepping on paper. Remember I told you the floor is my desk here. It's the F weight. Think about y. You have the tension pulling it this way and weight pulling it this way in the negative direction. So it's weight of y plus the tension. Now, for this one, we can put MA. The weight is mg. But now I forgot to put my symbol. For this one, weight is pulling it in the negative direction. So the weight will now be negative, but the tension is going to be pulling it in the positive direction. All right? Sorry. So it's going to be negative mg plus t. Okay? And so let's plug in the numbers. MA. So the mass of y is 10 times a. Oh, wait, 10.0. Oh, yeah, that was probably also 20.0, wasn't it? No, I don't know why I did that. Oh, well, it doesn't matter. I'm not going to get trapped up on that. Okay, negative mg. So that's going to be negative 10 times 9.81 plus t. All right, so 10a equals, I can do that with a calculator, right? 90.81. Negative 90, sorry. Negative 98.1. Okay, negative 98.1 plus t. I guess you could put brackets around that if you want to be around these two numbers, just to make sure you know that. But that's the only negative. Okay, now, all right, so here are my two equations to combine as a system of equations. And let's see, one of these I can solve easier for t. This is actually the one that looks like t's already positive. So all I gotta do is move that to the other side. So 10a plus 98.1 equals t. See how I did that? So 10a, move that over, plus 98.1 equals t. So now over here I can plug that in for t for this equation. So 20 times a is equal to 19.6 minus, I'm going to substitute in, all of this is t. T is 10a plus 98.1. It's going to become minus in a minute though. Okay, so all I did was I just substitute, I solved for t, I'm going to sub it in there. So 20a equals 19.6 minus, now watch your negative sign, minus 10a and minus 98.1. So now I can bring all of this to the left. Oh wait, bring all of this to the other side. So I'm going to add 10 to both sides. Add 10a and add 10a. Okay, so it's 30a. It'll actually be just 2 sig figs in it. 30a and then 19.6. If that cancels out, 19.6 minus 9.81 is 9.79. actually just 9.8 because I'm going to, let's see, I will do the sig fig there. It's going to be 2 in your answer. Okay, so now to solve for acceleration, divide both by 30. So your acceleration equals 9.8 divided by 30. And it's a small number. 9.8 divided by 30. 0.33 meter per second squared. Okay. I didn't do anything wrong here, right? Okay. 20 is 19.6 minus t. Minus t is minus 10a minus 98.1. Seems like a very strange, very small answer. 30. Yeah, 9.8 divided by 30. That's correct. So 0.33. Not a very big acceleration, but it is accelerating, and it'll keep going down, getting faster and faster at that rate. Now, to find the tension in the cable, so that's acceleration. The tension in the cable, I'm just going to plug in my 0.33 right here. So I'm going to have to erase this part of the problem if you want to take a screenshot or whatever. Okay, you can always just go back. 0.33. I'm going to plug in here. For A, I'm going to put in 0.33. So 10 times 0.33 plus 98.1 is the tension. So that's going to be, I can do that here. 0.33 times 10 is 3.3. And let me just check. 3.3 plus 9.81. So 9.81, 3.3 is 13.13. We'll just say 13. Well, no, 13.1. 13.1 newtons is equal to the tension in the cable. So 0.33 and 13.1 newtons for that. So that is how you do a little pulley problem. Now, what do we do? The other type of problem is when you have it on the ramp or on the inclined plane. And you're going to do it the same way, but now you got to think about, well, you'll see. Here we go. So I've got X and Y. A little pulleys right here. So an object hanging on this side, and then an object going down here. Well, I'll just put it like that, maybe. On the ramp, X is here, and Y is here. All right, now for this one, it's still going to be the same numbers, 20 for X and 10 for Y. 20 kilograms, X is 20 kilograms, and Y is 10 kilograms. But now remember this, remember to draw your vectors. Okay, so here's your weight, then here parallel would be your Fx, and then there's your Fy. Now, we're not going to have any friction in this one, so we shouldn't have to worry about Fy much. The angle is 25 degrees. So 25 degree is the angle, and that's going to be the same angle there, 25 degrees. So the very first thing I'm going to do, before I mess around with anything, I'm going to go on and find out what Fx is, because I know Fx is the force pulling X down the ramp. We're ignoring friction in this problem, okay? So that means I'm going to use sine. Oh, and I need to know F weight on this side. F weight of X, if you want to call it. Well, F weight. So for X, F weight equals mg. Oh, I'm making a big mess. I'm going to take off too much of the board. I'm going to try to do all this in the top. X, okay, F weight is mg, which is, we said X is 10, 20 is 20 kilograms, same as the other problem, times 9.81. I could just use the same number, couldn't I? Well, I don't have it written on the paper. I'm out on the board. You have it on the paper, though. 19.6. This time, we'll just make it 20 newtons this time. Make it less numbers to work with. Now, you've got to find Fx. So you know that'll be sine of theta will be Fx over F weight of X, okay? So sine of 25 is Fx over 20 newtons. So sine of 25 times 20 is 8.5 newtons equals Fx. So Fx is 8.5 newtons. I'll just kind of put that, and it's pulling that way. Now, we have to decide here, if this one weighs 20 kilograms and this one weighs 10 kilograms, you might be thinking, well, it looks like it's going to go that way, right? Going to fall down that way. Well, maybe not necessarily. Actually, you can figure it out right now. You could have picked this to be positive and negative, but once you find Fx, look, Fx is pulling at 8.5. 8.5 is actually what's pulling it that way, and that's less than 10. This thing is actually going to go up. This is a cool example of showing you how with an inclined plane, something that weighs 10 can lift up something that weighs 20, twice its weight with a 25-degree angle like that. You should be able to do the same. So you should be able to pull twice your weight up, you know. Or if you hung on it, put it this way, if you hung on it, you'd be able to pull someone up that's twice your weight. It's pretty neat. Okay, so anyway, so we know it's going to go in this direction, so I'm going to let that be positive, and this direction will be negative. Down will be negative here. This way will be positive. You could have put it the other way if you wanted to, all right? But then your answer in the end will come out to be a different sign, and that's okay. All your math will be correct if you're consistent. It's just that if you get it to be a weird symbol, then you'll know, oh, it goes the other direction. Okay, so I'll try and class them to show you one like that. But 8.5 newtons. Okay, so now what I'm going to do is I'm going to make my equation here. Oh, and I might as well go in and find F weight for, that was for X. And for Y, let's just put it up here. Does it fit? Oh, it didn't really fit there. Oh, well. I'm just trying to put it, get some space on the board. I'll put it out. We'll do it when we, okay, I'll do it over here. F weight for Y will equal mg. That's 10 kilograms times 9.81. Oh, I could have used that from the other problem too. So 9.81 times 10 is 98.1 newtons. Okay, or 98 newtons, we'll just say. Okay, so Y is 98 newtons. Now, I'm going to make my two equations. So for X, the equation will be the net force on X is equal to, it's going to be Fx is going to be pulling it down the ramp. That component, Fx, and we know it's also, that's going to be the negative direction. Negative Fx, and then the tension will be resisting it. So it's like Fx is pulling it down the ramp, but the tension in the cable is resisting that, pulling it the other direction. So it's positive. Okay. So MA equals negative Fx is negative 8.5 plus T, and the mass of X is 20. So again, we have 20A. I'll put a dot there to make the sig fig count. Negative 8.5 plus T. For Y, for block Y, it will be the net force on Y will equal, gravity's pulling it down straight there, F weight. The full F weight plus the tension. Now, which one's negative? We said we'll let that be positive going down. So positive for my weight. Okay, if you want to put the little arrows there, you could. I didn't put them on all those. And for the tension, the tension will be resisting it in the opposite direction. So it will be negative. So you have MA equals the weight we already found over here for Y. Mg, 10 times 9.81, 98 newtons. Okay, 98 newtons plus, or minus T. And so MA, the mass of Y is 10 times A is 98 minus T. I just use 10 point this time instead of the 10.0. Normally I will give you probably on a quiz 20.0 and 10.0, but I got to at least have two sig figs. I'll put a dot there for these sample class ones. So here are the two. And once again, this is going to be the easier one to solve for. 10A minus 98 is equal to T. So 10A minus 98 equals to T. Using the substitution method, I'll sub that in over here. Well, actually, I did the other one last time, didn't I? Oh, no. That's not true. Bad development. well, that would be negative t. I could solve, no, this is the better one to solve for. That's a positive t. I'm glad, see, if I had done that, I'd have a negative t. That can mess things up. So you can still use it to solve for t, multiply both sides by -1, but let's just go on and do this. It's going to be easier. 20a plus 8.5 is equal to t. So if I add 8.5 to both sides, that goes away, and that side becomes plus 8.5. So 20a plus 8.5 equals t. Now I'll substitute that one into this one. So 10a is equal to 98 minus, and I got to put all this in brackets, 20a plus 8.5. It all fits on the screen, right? Yeah, this barely does. I don't, but it does. 10a equals 98 minus 20a. Well, okay, 20a, that dot, don't be scared of that. Minus 8.5. Don't forget, the minus goes distributive over both of these, minus 20 and minus 8.5. Okay? So then, 10a, I'll add 20 to both sides. 20a, that is. So that's 30a again, equals, I don't know why I put a 10.0 there. Okay. 30a equals, that'll go away. So 98 minus 8.5. Actually, I can do that without a calculator. That's 89.5. 98 minus 8.5, 89.5. Divide them both by 30. So the acceleration of this system will be 89.5 divided by 30, which is 2.98. This is more like it. Or actually, we'll just say 2.9. It could even be 3.0. I'll put it 3.0. 2.98 rounded to 3.0 meter per second squared. That's your acceleration. And now to find your tension, this works out good. I'll plug it in up here. A is 3.0. So 20 times 3.0 is A, plus 8.5 will give me the tension. So I'm just subbing right here to find the answer. 20 times 3 is 60, plus 8.5. No calculator needed here. So 68.5. Really, it should just be 68 or 69. It's probably better to say 69 equals the tension in the cable. For the sig figs, I don't really care about it so much in physics as I am in the chem classes. Okay, wow, that's a lot. And I didn't even tell you what problems to do on the beginning of the video. Let me see if this thing comes on. I'll tell you right now. My computer is not wanting to wake up. Well, I'll have it written on the lesson. Yeah, I'll just have it on the lesson for you. So, all right, that's all. Thanks a lot. Okay.